and these vertical lines which is joining from the crown to this horizontal rings are known as medians. Now we will consider what are the forces that is acting on this hemispherical dome or spherical dome. So usually when you are considering a beam which is being subjected to bending, if we take a small element over there, we can say that there will be stresses in x and y directions. Let me call this as sigma x and sigma y. Likewise, when you are considering this spherical domes, we will have two forces. One is hoop force and second one is meridional thrust. So hoop force will be represented by H and meridional thrust will be represented by T. So if this is the dome and we have this circular rings, that is latitudes, and then from here we will have this medians. Say if this is the axis, say for example if we are considering a small portion like this, small element like this, and we'll have this element will be suffering from hoop force and meridional thrust. That is, say for example if this is the spherical dome, there will be certain inside pressure, and due to this inside pressure this will try to burst off. There will be some tension over there and this will try to burst off. So hoop force in this spherical dome is considered as a resisting force which opposes this tension. So this is a resistive force which prevents bursting. So this is the hoop force H. And next is meridional thrust. That is, meridional thrust is a force which is opposing the vertical forces. That is, due to the self weight or due to other weights, this will have a tendency to elongate. So those forces which are trying to resist this vertical forces are treated as this hoop, this meridional thrust. And usually this meridional thrust will be, these forces will be parallel to the medians. That is, the median is the vertical lines and hoop force will be parallel to this latitudes. So these hoop forces and meridional thrust are actually compressive in nature. So we will actually find out, say if this is our hemispherical dome, what we will find out the hoop and meridional thrust at different locations. Say if this is the center of this sphere and this is the radius, this is also the radius. What we will do is we will find the hoop and meridional thrust at different locations, starting from this. If this is the axis, so from here we will count different angles, and this is the theta, that is the angle between the axis and any point on this surface. These two, this is angle theta. So what we will do is we will find out the hoop stress at different locations on this dome. We will find out at different locations, and out of this we will find out whichever is the maximum, and for that maximum force we will do the design.